Well, welcome, class. We have a very special guest speaker for us that's going to talk to our class tonight. This is Byron Bass. Byron graduated in May. Byron started this project on schema-based instruction for math last year in Special Ed 620, and then he continued on and implemented this for his Master's Plan B project. Byron's currently teaching at Castle High School, Resource and Inclusion Math. And with that, I'm going to let Byron take it away and talk to you.
Hi, everyone. So this is my presentation on schema-based instruction. So what I did, I developed this presentation as part of my Plan B project, but I did learn about this strategy in SPED 620. So I'm just going to go over the strategy, how it's used, and then how I implemented it in my project. So I had to make an online curriculum as part of my Plan B. So I adapted schema-based instruction so that it can be implemented in kind of an online setting. And the program that I used to do this was Desmos. So I'm actually using Desmos to give this presentation. And then I'm going to show how I kind of altered it in the online setting, but also just talk about schema-based instruction in general. So let's go ahead and get started. So schema-based instruction, it's an intervention that's designed to target mathematical word problem solving. It teaches students how to identify the structure of arithmetic word problems, or in other words, word problems that use like addition, subtraction, multiplication, and division. In schema-based instruction, students learn about different problem types, and we call these types schemas. And each schema has its own specific solution pathway. The two main schemas are multiplicative and additive. So students identify word problems, the word problem schema, and then they follow the schema strategy in order to solve a particular problem. So the images that you see on the screen right now, these are graphic organizers for all of the additive and multiplicative schemas. So schema-based instruction is useful because it works for any arithmetic word problem, even the word problems that use combinations of additive or multiplicative schemas. It's important to note that schema-based instruction is distinct from using a keyword strategy. Keyword strategies use keywords to determine a problem's operation. Schema-based instruction teaches students how to identify the entire structure of the word problem, which allows a deeper understanding and causes less mistakes. So let's go ahead, and here's an example of an additive schema, and this is the change schema. Change schemas involve an increase or decrease of some initial value. When students first learn a schema, they'll learn how to identify a schema with story problems. Story problems are word problems that don't have any unknown information. So we'll see here. Gabby the snail had 34 cookies. She baked 946 more, and now she has 980 cookies. There's nothing unknown. We're given all the information that we need already. So the first step in solving something like this is to read the problem out loud and to retell it in your own words. So let's do that. So Gabby the snail had 34 cookies. She baked 946 more cookies. And now Gabby has 980 cookies. After you read it out loud, you want the students to kind of rephrase it in their own words so that you know they understand. So I know that we started with 34, and then after baking 946 more, we end with 980. So we start with a value, we get more, and then we end with a higher value. So I'm just going to take the problem. I'm going to copy it and then paste it here. And then that way we have our problem right above our graphic organizer, and I can even make it a little bigger. Okay, and then so the next thing that we want to do is we want to underline not our keywords, but our important information. So I'm going to go ahead and underline the information that's important. So Gabby the snail had 34 cookies. That's important, right? That's how much she had. She baked 946 more cookies. And now is important because this is showing that we're kind of ending with something. Now she has 980 cookies. So these are my important pieces of information. So I'm just going to take this information and put it into my graphic organizer. At the beginning, I know that I had, let's make this a little smaller, 34 cookies. The change, we baked 946 more cookies. So we are adding 946 cookies. That's our change. And then we're going to end with a value, and our ending value is 980 cookies. 980 cookies. And we know this because that's how much now we have 980, right? So that's our end value. And then once we do that, we would just rewrite this graphic organizer and change it into a math sentence, right? And so that's just basically a math equation. So then we're just going to take it and kind of rewrite it. So we started with 34. Our change was plus 946. And then we ended with equals 980. And there we go. That's and then so how do we know this was a change story problem? We've kind of asked the students that to see what part of this problem told us that it was changed. And the answer could look something like, well, we started with the value, we increased the value, and now we had an ending value. And then moving on. So once students begin comfortable with learning how to identify a schema and using the schema's graphic organizer, they'll begin working with problems that have unknown information. And we don't call these story problems anymore now. These are called word problems. And you'll see here's a key difference. How many cookies does Gabby have now? You'd go through this the exact same way. The problem identification steps would be exactly the same. You'd map the problem onto the board, fill out the graphic organizer, write your math sentence, except this time, I'll kind of show you what goes on. So I'll spare you the details of solving this time, but we'll go ahead and paste our problem onto the board. We'll underline our important information again. So again, 34 cookies, 946 more cookies. And now we want to know how many cookies does she have now, right? So mapping our information will look very similar. We start with 34. Our change was plus 946. But our ending value, we don't know. It's asking us how many. So we would tell students to put a question mark or something that shows that we don't quite know how many we have. And then the next step would be to map this graph, to take the information from the graphic organizer and then write a math sentence to solve it. So we'd have 34 plus 946 equals some unknown value. Now, ideally, before you do this, students will have experience with solving one-step equations, which this is. This one's kind of phrased nicely because the question mark's at the end and both of the known values are on this side of the equal sign, but that's not always going to be the case. So you do want students to be able to move values around ideally before you start this type of instruction. But then what students can do is they can solve it. And then you can even use the calculator, which I've embedded into Desmos, and they could say 34 plus 946. Well, that gives me 980. And then so we could just write out our the complete answer. So Gabby has 980 cookies now. And again, you'd ask students how they know it was a change word problem. Something that I wasn't doing that you should do while you do this with the students, you'll notice that I have the strategy steps written out right here. You'll want to go over each step with the students and tell them with the steps listed out here, what step that you're actually working on so that they can follow along the entire time. So like, for example, before I underlined my words, we would have seen that step 3 underlined the important information. So you'd want to do that for each step, point out the step and kind of work through it when you're working on this with students. And students should ideally all have their own copies of the steps so that they can kind of go through and work on it and kind of get to know the steps really well. When students demonstrated that they have these steps memorized, right, and that they need less assistance, you can start to fade your support. So the way that I did that is I kind of took away the steps, and you could take away the steps and do the same type of thing, right? And this is the same word problem. So then once students feel like maybe they don't need the graphic organizer anymore, and they feel like, hey, I know change problems, I know how they work, I don't need a graphic organizer, you can have them draw their own. And then so here you'll see that there's a blank whiteboard for the students to kind of draw their own graphic organizer and work it through and solve problems in that way. So then that'll kind of make them more independent problem solvers while still thinking about the structure of the word problem as they go, right? Yeah. So it's important to use direct instruction when teaching schema-based instruction. So each schema is going to require 6 to 9 lessons, depending on where your students are. And each lesson should take up to 45 minutes each. After learning 3 schemas, teachers should hold 2 45-minute review sessions to review the 3 schemas. Schema-based instruction has been shown to be effective for a small group or a whole group instruction. So when I created my online curriculum, so yeah, this is basically for adapting schema-based instruction to online instruction. This is something that I had to do. So I had to think about like what are the qualities of online instruction? And this might be relevant to you because we're in uncertain times, and who knows if we're ever going to go back to online instruction. And some of you may currently be using it, I don't know, right? So but I use Google Classroom, and I organize all my lessons into modules, which is something that you should do for online instruction to make it kind of nice and organized. So for example, each schema was its own module that contained multiple lessons. I created videos for each module modeling how to interact with the Desmos lesson. And as an important thing to note is that the videos were a supplement for modeling during instruction and not a substitute. So it's always important to have plenty of in-person modeling, or as much as possible, right, when you're teaching this skill. And then I had to use digital tools that were relative to the activity and not simply used for the sake of using the tool, right? So any digital tool that you use should actually be productive in helping the students meet whatever goal you're trying to help them meet. And any tool that you use, you got to teach the students explicitly how to use it before using it as part of a lesson. So if you did want to say, hey, I want to teach schema-based instruction and I want to use Desmos, make sure they know how to use Desmos before you use the tool, because there's a lot of complications in Desmos that students will understand automatically. And this goes for tools that aren't digital as well. If you want to help them solve problems by using, let's say, manipulatives, and you want to help them solve the 1 and 2 step equations using math manipulatives or algebra tiles, you got to make sure they actually know how to use the tiles before just handing it to them, right? So that's an important thing to do. These were my research questions for my project. I wanted to know if schema-based instruction could be adaptive in an online setting effectively. And I also wanted to know if secondary math and special ed teachers perceived it as effective. So that was just relevant to my Plan B paper, right? And this took place on the windward side of Oahu, and I showed it to 12 teachers. And these are the results in case you're curious. This is what I had to do for my Plan B project. It did turn out that the participants found schema-based instruction to be an effective intervention. And most of them said they would use my curriculum, so the curriculum that I developed for my project, in a distance learning setting. Yeah. So the rest of this is kind of just specific to my project. But anyway, so that's schema-based instruction. And that's what I had put together.
Well, I love you presenting schema-based instruction, because I think just reading about it in an article, it is a little bit abstract, However, I think that there's a lot of value here, and you brought up a couple of really important things. One, they're learning not just the keyword strategy, which keywords are great. And you used keywords when you were giving us the demonstration. Go back just a couple of slides, because when you were underlying, you used a keyword that she baked more cookies, now she has. So those are great keywords. But if kids only learn keywords, they're not learning how it comes together. They're not learning the process, and they can make mistakes. And you said one of the reasons we want to use this strategy is that they can make mistakes. So you can memorize, in all, the sum of, now, resulting in, you can use all that. But what if the word now appeared earlier in the sentence? Then are they going to get messed up on that? you know. So the whole idea of really looking at a problem type, and being able to identify that, I think is really good. You did bring up a couple of other things that I wanted to point out, and I really liked the scaffolding. So at first, you have, and I wrote this down, I took notes. So you have all the problem identification steps, you have all the information, and you practice identifying the structure and putting it into the graphic organizer. Then the next step is have one unknown. Then the next step might be, yeah, the one unknown. And you're still identifying some keywords in there, but the entire strategy isn't just keywords. It's the structure, when looking at something. And this becomes super important when kids are doing things in real life. Because if you need to solve a mathematical problem, it isn't always presented to you in a paragraph or sentence form. If you are trying to figure out how many square feet of carpet you need for your living room, you're not presented with a sentence. You need to actually figure that out. So you kind of need to know, I have this much, I need this much more, what's at the end? So I like that. So here you did this gradual release here. So now you have one unknown. Then your next step was to just have the steps aren't there anymore. So you did that. And then you did another one where they just have like a whiteboard. So there was 4 different ways to scaffold the instruction where typically this is what students would see. Gabby the snail had 34 cookies. She baked 946 more. How many does she have now? That's what kids usually see. And when we go backwards, there were 4 scaffolds to get to that point. So I've been talking to the class about specially designed instruction. So in an inclusive classroom, you might get just the end slide. What the teacher can do is give some small lessons on how to use this strategy. And then in time, practice, experience with it. And this doesn't take the place of the general ed instruction. You would teach the strategy in addition. Tell me more about how you've used this, or you probably don't have an example on your slide, but what a multiplicative, that's hard to say, multiplicative, what would that look like? I
Sure.
think you did have one earlier about like the grouping. Yeah. Show
Yeah.
me one of those.
Sure. So a multiplicative strategy, this would be kind of the same idea, except instead of adding or subtracting, you're multiplying or dividing, right? It depends on how you want to solve it. But you're right, I don't have one handy, but I can kind of come up with a problem now, right? So let's say you have a bag of Skittles. So that would be the groups. Your groups would be how many bags of Skittles you have. So if you have 1 bag of Skittles and there's 3 Skittles in each bag, this problem would be set up 1 bag, 3 in each bag, something like that, right? And then you'd want to find how many Skittles you have in total. Any 3 of these could be the unknown. You could have I have 2 bags of Skittles and I know that I have 10 Skittles in total. How many Skittles are going to be in each bag if each bag has the same amount of Skittles? So something like that would be how a multiplicative problem would look.
Nice.
And what I said also is how they can be combined. Later on, when they become more advanced, you could have problems that require 2-step, like 2-step algebra problems, right? Where it's addition and multiplication or division. It will work too. You can combine multiple graphic organizers, solve one part of the problem first with one graphic organizer, solve the second part of the problem with the second graphic organizer. So these can be used for all levels of word problems as long as they're arithmetic.
Nice. Nice. Well, do you have any advice for anyone who is beginning teaching math? Like this maybe is their first year or maybe even second year teaching math in special education, but they were never a math teacher before. What kind of advice would you give to those people?
Right. So that's tough. I know what it's like to teach something that you're not experienced with. In my student teaching, I was teaching computer science, which I have absolutely no experience with as well. So that was a challenge for me. What I did, and no one's gonna like to hear this, but it's what I did, as I did extra work, right? So I would teach myself the content outside of the class so that I understood it. But then the other important thing to remember is it's okay to make mistakes. I think students actually like that as long as you catch yourself and you're like, oh, I messed this up and here's why. That shows the students like, hey, I'm a person too and I make mistakes. And also like it helps them see how to self-correct and helps them know like, because they're going to make mistakes too, and they'll know like, hey, if my teacher makes mistakes and it's okay with them, it's going to be okay with me. So if you don't know math, I guess just be patient with yourself, right? Allow yourself to make your mistakes up on the board in front of the students and don't let it stress you out, because I honestly think that's super helpful. Even as I majored in math, right? So I'm very comfortable with it, but I even make mistakes in front of students, sometimes on purpose, so that they can see like kind of what it's like and that it's okay. So I think it's a strength to go in and not have a strong math background. I think that would be fine. My last piece of advice for this specific strategy would be don't let it stress you. Like it's hard and the students will be confused. And that's why you need so many long periods of instruction with it, right? So don't expect to go in there with one lesson like, hey, this is the unit on word problems. We have a week to do this. Let's use the strategy for a week. That's not going to work, right? You got to kind of use this strategy. So I am trying to implement it, and I started on day 1 of the school year and we've been using it this whole time. So it's taking time and they're not there yet. We just got through additive, right? So it takes a long time to kind of implement this strategy and make it work. And they're going to be confused and it's going to seem hard, but the more you do it and the more time you put in, by the end of the year, they'll probably be more comfortable with word problems. It really doesn't take that much time, but it's worth it to kind of use. You just got to have little chunks throughout the day. It doesn't have to be your whole day of instruction. Right. And I'm not using this with fidelity either because I don't have 45 minutes each session that I can dedicate towards this, but I do take little chunks of time in my instruction to kind of go through this strategy with them. So do what you can. Yeah.
No, I think that's a really good point too, is because there is the content that needs to be taught, but the special ed part is being able to do the strategy instruction. That's where you can split your time to know that you're just going through and you are practicing, rehearsing, you're doing this strategy ongoing. So whether it be a vocabulary strategy, a math strategy, that strategy instruction is a part of every day, just a little bit every day. So I think that that's a really good lesson too. I really like this, and teachers talk so much about they don't, kids have difficulty with word problems. So it is worth it. It is worth it to take the time to learn the strategy. One more thing I was going to add is perhaps the online method that you have, like this module, may be a chance for more practice. So even though our classes are back to face, there are some kids who need more practice than others. Therefore, some of the online instruction, the online modules like you had here, may be a way for them to get some extra practice.
Absolutely. I still use Google Classroom and I keep a lot of my stuff digital, even though we are in person, for that very reason. And it helps students who are absent kind of access the content too. So it's just, I don't know, I think it's useful to have things online if you can.
Well, I want to thank Byron for being here. And you know what? Thank you. I want everybody in our class to see it's possible. You do it. Look, we've got an example here, and you made it to the end, and now you're first year teacher without having classes at the same time. You were a teacher before, but now you are a teacher without having night classes. Yay! Everyone congratulate Byron. Wonderful project. You finished. And thanks for spending some time with us.
Thanks, Dr. Black. Thanks, everybody.
Okay.